All right, guys, let's go on and get started looking at these here. So we're given a figure of a moth, it looks like, and some charts and graphs. And what we're wanting to do, especially in this here, is supporting a hypothesis. Now, the first question, the scientists hypothesized that the population of Melanic peppered moth decreased with the decrease of particulate air pollution because the moths were then more susceptible to predation and thus could not pass their genes on to the next generation. Do figures 2 and 3 support this hypothesis? So what's one of the key things in that questions? What are we looking for? 2 and 3, and what else? In particular, let's see here. The negative population with the decrease of particulates in the air. So what are we expecting to see? A decrease, because they're supposed to be decreasing, yes? So if we look at figures 2 and 3, numbers of moths and number of melanic moths, well, in figure 2, the melanic percentage is going down. The number of total moths is kind of up and down. There's not a consistent deal there. Now in figure 3, the suspension particulates per gram is going down. The mean SO2 concentration is going down. Both of them are decreasing, yes? Okay. So we have this here. No, the decrease of the peppered moth population correlates with the overall decrease of moth numbers. Wait a minute. In figure 2, does that actually line up? Because are the overall total number or the population of total moths decreasing across the whole time period? No. So that means that's automatically out because it doesn't agree with the graph. Question 2, yes, the decrease of the peppered moth population correlates with the decrease of SO2 and particulate population. Well, melanic moths is decreasing. SO2 is decreasing. Those are both lining up, yes? So it could be B. C, no, there was no noticeable decrease in the number of the peppered moth population. Well, no, that doesn't even line up with the graph, right? Because we do see a decrease in the peppered moths. Well, that ain't it. Yes, the decrease of the peppered moth population and the total moth populations correlates with the decrease of SO2 and particulate population. Well, the number of the total moths, was that constantly decreasing? No, so the only one that it could be is, so B is the correct answer. And that's it. And really, what were we doing? We were looking at the figures and what was given to us and seeing which one does it support. What data do we have that supports it? So B is the one that works. Question number 2. Suppose it is discovered that rising population pollution levels of certain carbon compounds not tested in the study led to an increase in the overall percentage of melanic moths in the general moth population. This discovery most strongly contradicts which of the following figures? So what are we saying? That it's going, what? That the population would be going up, yes? Well, wait a minute, which one of the figures deals with our melanic moths? Top of figure 2 is the only one that deals with melanic moths, isn't it? So the correct answer is, yeah. That's it. Question number 3, suppose a separate study confirmed that the percentage of melanic moths decrease with decreasing levels of pollution. Do the results of study 2 support this statement? The number of melanic moths fell in Detroit, but increased in Great Britain. Well, okay, so it tells us that the percentage of melanic moths decreases with decreasing levels of pollution, yes? So if we look at the pollution levels for both Detroit and Britain, they're both going what? Down. Okay, so the number of Atlantic moths fell, but increased. Okay, well, we know that's not true because the graphs tell us that they're both going down, which means A and B are both gone. Now, even if we don't know how to proceed at this point, we have a 1 in 2. We have a 50-50 shot at just guessing it. Okay, so no, because the pollution levels in both Detroit and Great Britain fell, which would indicate a decrease in the percentage of melenic moths for both countries. Well, yes. D, no, because the populations in Great Britain decreased while the populations and levels in Detroit increased. Well, no. It's C. Now, I would advise on making sure to read through the entire question or answer, because sometimes they will throw information at the end of it that'll mess it up. So just make sure you read the answers completely. Well, we knew that A and B were gone immediately because they both said, yes, it supported it. But we know it doesn't. So these two here. No, because the populations in both Great Britain and Detroit and Great Britain fell. Well, if we stop there and it said something like, which would indicate an increase in the percentage of melenic moths, well, no, that's contradictory to what it's saying. Does that make sense? Sometimes they'll throw that in and have something very similar to both, but that glaring statement at the end. Learning target, supporting hypothesis and information. Well, a statement is an expression in speech or writing. A conclusion, judgment or decision. Claim, an assertion or statement often without proof. A hypothesis, an explanation based on limited evidence used as a starting point for further investigation. Prediction. You all know what a prediction is? A statement about what might happen or might occur in the future, something that we expect to happen. We're going to predict what is going to occur. Evidence, information supporting that something exists or is true. Results, an outcome that is caused by something else. Data is our facts and figures. Yes? So can we prove anything true in science? Science is used to prove stuff true? No. That is one of the biggest things, especially at JBU, that they did emphasize, that science does not prove true. Doesn't prove stuff true. We find stuff that correlates or is consistent with what we think should happen, but we never prove something true or false. Because gravity, we know it to work, to be true. Yeah, because as soon as something that is a contradictory to it, we reevaluate. The scientific method is we make a hypothesis, test it. If it does not prove to be true, we go back and change the hypothesis and test it again. And that's just the scientific method. Now, I know that these aren't in your note sheets, but we're going to look at these here. So we have three cheerleaders here. Now, the purpose of this section is to help y'all learn to isolate evidence from surrounding content and use it to support a scientific claim or hypothesis. Questions on the ACT that test today's lesson objective are looking for a statement that is supported by the passage. The ACT uses several variations of wording to ask a similar question. Some questions mention a statement, conclusion, claim, hypothesis, or prediction. All of these terms are usually referring to the same idea. Now, looking at this here, which team are the cheerleaders supporting? How do we know that? That's on their jersey, because we can see that that is our evidence to support which team they're supporting. What sport's being played? How do we know it's football? Quarterback. Block the pass. Well, does block the pass really tell us what sport it is? No, because it could be football, it could be soccer, it could be hockey, basketball, because there's a lot of sports that use passing. But quarterback, that's one main sport. Now, is the team on offense or defense? Block the pass. Because, I mean, it could be on offense, but that's be a little contradictory there. So, and that's it. So all we did was we utilized this one picture and got multiple pieces of information from it. And that's really what we'll be doing with most of the science passages, is looking at what they give us and trying to support or identify information that we are given. Because when you see the word support, look for cheerleaders in the passage. Whenever an ACT question asks which statements or hypothesis is supported by data or results in the passage, find your cheerleading sentence and choose the answer that corresponds to it. Just like we did in this here, cheerleading sentence. Which scientific claim are these cheerleaders supporting? So we have, I'm ice cold, I'm full of hot air, I'll rain on your parade. Well, so let's look at this here. On average, the Atlantic Ocean is the saltiest of the Earth's major oceans. Do any of those three statements really support that? Okay. Dogs can hear sound at a higher frequency than humans. I mean, it is true. I mean, both of those are true. Alexander Graham Bell is credited for the invention of the telephone. Water has 3 different states: liquid, solid, and gas. Because I'm ice cold, so ice is solid. Hot air is, and rain is liquid. So it would be D. All right, so 3.31. So again, we're right there on the note sheet. Page 53 in y'all's note sheet packets. So there is a good bit of information there. But let's look at question 1. Which of the following is best supported by figure 1? So we can look at figure 1, and we're talking about this here. Chlorophyll A absorbs the most light at blue and red wavelengths. So chlorophyll A. So we're looking at the solid line, yes? So where is it highest? Blue and red, yes? Okay, well the correct answer is A, because we looked at the chart, yes? So the correct answer is A. Okay. So we're looking at a different set of data because they gave us 3 different charts, yes? And some passages. Question 1. Which of the following statements about the CA:P ratio in various dog foods is best supported by the information in figure 1 through 3 over the course of 12 months? Okay. So A, the 1.2:1 CA:P ratio resulted in the smallest total weight change for breed 1 puppies. So figures 1, 2, and 3, which one is that talking about? That one's talking about a specific one. Figure 1. Where do we see that number? It's right above the x-axis, isn't it, in that diagram? Because it said food X with a 1.2:1 right there. So question, or answer choice A is talking about the first figure. Breed 1 puppy would be the line with a circle spaced out across it. So it's saying that it resulted in the smallest total weight change. So the smallest amount across all of them. Well, that's going from 2 to 8 pounds. So that means a change in 6 pounds, yes? Is there any other figure or line that's smaller than that? So Chloe, which one's smaller? Or breed 1 on figure 2? Yeah, because that's smaller. That's not even 2 pounds, or it's a little over 2 pounds. Because it's like 3 pounds, a little over 3. Okay, well that's less than it, yes? So can it be answer choice A? No, because we found one that had a smaller amount. Okay. 2:1 CAP ratio resulted in the smallest total weight change for breed 1 puppies. Well, okay, so figure 2. Breed 1, well, we just said that kind of overall was a smaller amount change, yes? Okay, so that could be it. Now, C, a 1.:2 CA ratio resulted in the smallest total weight change for breed 1 puppies. So we look at figure 3. Wait, what happened to breed 1 in figure 3? Well, it went from like 3 to 2, yes? Wait a minute, that's negative, isn't it? So that would be the smallest, yes? Because it looked like it could be B, but C, well, that's even smaller, all resulted in the same, well, no. They all aren't in the same, so the correct answer is C. All right, guys, let's wake up. I know this is somewhat boring, but let's wake up. Thank you. But hopefully, as y'all are noticing with this here, is there a whole lot of stuff that we're having to totally think about? I mean, a little bit, yes. But how much information are we having to bring into this test? No, where are all the answers? All the answers are contained within the graphs, charts, tables, or passages. So all the information we need, or the correct answer, is essentially given to us. We just need to find it. We just need to find it. Which of the following statements about breed 2 puppies is best supported by the information from figures 1 through 3? Well, what's happening on all 3 figures? It's all increasing, yes? By a decent amount. Breed 2 puppy feed, the thing ratio of food showed the most growth. Breed 2 puppy feed and this here showed the most growth. And this one here showed the least growth. And food choice did not affect the puppy growth. Because if we look at the first figure 1, well, it starts a little bit below 4 and ends up right above 12. So we can say that's a little over 8 pounds for figure 1. Figure 2 starts at 4 and goes to a little bit above 12. So we're looking at a little bit above 8 pounds. Figure 3. Well, it starts at about 5 and goes to about 11, yes? Well, the first 2 are about 8, and the last one is less than that, yes? So can we say that the food didn't affect it? Well, no, figure 3 proves that wrong, yes? Well, the first 2 show most. Well, they're the same, so it can't be them. It has to be, oh, sorry, it is that one. And that shows, yep. Exactly, because in figure 1, the change in weight from breed 2 is like 12.5 minus 3.5, which is 9. In figure 2, based off of 12.5 minus 4, which is 8.5. So we get this here. Okay, let's do an experiment. 2 scientists have an argument, and we're going to see who is right. Scientist 1 says that girls are better than boys at kissing their own elbow. Scientist 2 says that boys and girls have the same ability to kiss their own elbow. And scientist 3 says no one can kiss their own elbow. So what do we think? Because it's not possible to kiss your own elbow. It just doesn't work. So here, because, I mean, we could do it, but it's just not possible. Well, not possible. Because, well, actually, you're not double jointed. Because double jointed, double means two. Because it's not possible to actually have two joints in the same spot. But it's not, actually, it's gotten the nickname double jointed. It's actually hyperextending the joint past where it's normal. So it's actually hyperextension. But I mean, to do that, you would almost need to be able to super hyperextend it. Actually, probably have to go backwards and up. Shoulder to get it. Yeah, because I think it's the collarbone and the length of your arm to really get the right angle. But it's really, we could do it and claim and see induced proofs to get there. Now, okay. Work through the ACT, 2 ACT examples in the student's workbook as a class. So we're looking at 3.32. So we'll just move on with that there because that was pretty straightforward. I'm not going to force y'all to try to lick your own elbows. You'd probably have to cut the bottom part of your tongue to separate it. Because have y'all seen the pictures of Kiss and his tongue extended because he had that cut so that he could actually extend his tongue out farther? Yeah, it's weird. So let's look at this here. Now, which of the hypotheses, if any, is strengthened by the results of experiment 3? Let's see here. Actually, I think I'm still on. Sorry. This is. Here, make sure this is with. Yeah. Okay. So we're looking at this here. Which hypothesis, if any, is strengthened by the results of experiment 3? Or hypothesis. Yeah, experiment 3. Yeah. Yeah. So experiment 3, so roots, stem, leaves, fruits, total. So we're looking at table 2. So hypothesis 1, ultraviolet light, while generally harmful to living creatures, has a beneficial effect on plant growth in small quantities, is hypothesis 1. Hypothesis 2, the color we see when looking at something is the wavelength of light that is being reflected back, while the other wavelengths are being absorbed by the object we are viewing. Therefore, exposing a plant to predominantly green light will negatively affect its health. Hypothesis 3. Some wavelengths will positively affect the growth of plants, some will negatively affect the growth of plants, and others will have no effect at all. The optimum color blend is one that eliminates the wavelengths that do nothing or harm the plant. Okay, so we're actually looking at table 1, not table 2, because table 2 doesn't have anything to do with wavelengths. No. Table 1 has experiments going down, then we have ultraviolet, blue, green, and red. So experiment 3, ultraviolet, it has a number of 0. Blue, it has, green is, and red is 0. Was one of those experiments talking about green light? Which one? Hypothesis 2. The color we look at when looking at something is the wavelength being reflected back, while others have wavelengths that are being absorbed. Therefore, exposing a plant to predominantly green light will negatively affect its health. Because that's the only one that talked about green light for experiment 3, yes? Because if we were looking at experiment or hypothesis 3, well, so some positively, some negatively, and have no effect, well, I should see numbers that are either going up, down, or having some variation. Okay, let's look at number 2. Hypothesis 2 would be most weakened if which of the following observations had been made. So hypothesis 2, the color when we look at something is light reflected back, while other wavelengths are being absorbed by the object we are viewing. Therefore, exposing a plant to predominantly green light will negatively affect itself. So green is going to be a negative, yes? So which of the following observations would be weakened if which of the following observations have been made? Experiment 1 had not resulted in plant death. Ultraviolet light, while generally harmful to living creatures, has a beneficial effect on plant growth. Okay. Experiment 3 has resulted in better than average plant growth. Okay, so experiment 1 had not resulted in plant growth. Experiment 3 had resulted in better than average plant growth, 7 or 10. So wait a minute, experiment or hypothesis 2, again, like we said with the first one, is mainly dealing with green light, yes? Green light is being bad, yes? Well, we just talked about experiment 3, didn't we? Because experiment 3 is dealing with 100% or 100% of green, yes? Resulted in better than average plant growth, yes? Well, hypothesis 2 said green light will do what? Negatively affected, yes? Well, if experiment 3 is saying that it's having better than average growth, well, that's going to hurt the observation, yes? Because when we say it's going to weaken the information, we're saying it's going to hurt it. It's going to prove it wrong, yes? Because it's almost the same as if we said that Ian wasn't here today, but Ian shows up. Well, obviously that doesn't work out because he's here. When we're weakening something or making something stronger, we're trying to find evidence that either A, supports it or is showing the opposite. Because, again, it's saying that what is going to weaken it? Well, hypothesis 2 says green light will negatively affect its health. Experiment 3 has 100% green light. Well, if it shows that it's making it better, well, that's not saying that it's hurting it. It's only making it better. Okay. So I'm not going to try to rush through the last of this. We'll do the 6 problems, or 5 problems together tomorrow. Then you will have the rest of the class time to work on the 5 homework problems and the 5 for points. Okay?